Hello learners, welcome to this course on practical machine learning using Google Colab. In this video tutorial, I will be discussing about fundamentals of computer vision part 2. So in this video tutorial, I will be discussing about image arithmetic, how to add two images, how to subtract two images, how to increase the pixel value, how to decrease the pixel value, and how to translate the image either towards left or right side or towards top or bottom, how to translate the image and how to rotate an image about a center point of an image or through any arbitrary point of an image, how to rotate it, and while rotating how to scale it. Such information I will be discussing here. And also I will be talking about resizing an image by maintaining the aspect ratio, which is one of the key concept in your resizing. Whenever we try to resize an image, we need to maintain the aspect ratio. And how to flip an image and how to crop an image. So these are the things which we will be discussing in this tutorial. So let us dive into Google Colab environment. So here I have created a Google Colab file on name basic operations on image with an extension .ipynb. So first let me discuss about on how to connect this code with your cloud environment. So Google Colab provides an online GPU or TPU which we can make use for our applications. So in order to do that, you can go to edit. We can select notebook settings. In notebook settings, you have this hardware accelerator. So here you can select a TPU or GPU, or none means it will make use of a CPU configuration. So let me use a GPU for this program. Save. Then we need to connect it to the cloud environment GPU. So in order to do that, you press this connect button. Now it is getting connected to the cloud environment. Once this is done, it will show an indication that it got connected. So right now it says initialized and connected. So the first operation which we are going to discuss is image arithmetic. So arithmetic in the sense we are going to do addition and subtraction operation. So when we talk about an image, so image is represented in terms of a matrix format. If it is a grayscale image, we will get a single matrix. If it is a color image, we will get three matrices, one related to red, another one related to green, and another one related to blue. So this matrices will have a value between 0 to 255. If I try to add two images, or if I try to add a value to a pixel, there is a chance that my value can exceed this 255. So for example, let us take in one image, I have a pixel with a value of some 200, and in another image, I have a pixel with a value of some 100. If I add these two images, what happens? 200 plus 100, it becomes 300. So 300 is not a valid 8-bit number. So we will be using an 8-bit number to represent the pixels. So that is why the range is 0 to 255. So now it exceeds the 8-bit value. We need to have an additional bit to store this information. So this type of situation can be handled in two ways. Either I can use a Opencv based arithmetic operation or NumPy based arithmetic operation. So Opencv is computer vision package, NumPy is a numerical Python library which is mainly used for a matrix computation. So there is a difference between how we do the arithmetic in Opencv and NumPy. So both will do it in a different way. So for example, in a NumPy, the addition or subtraction will result in a modulus arithmetic. So modulus arithmetic in the sense it will wrap around. So after 255, it will start counting from 0. Okay. So once the value exceeds 255, it will start counting from 0 and it goes on till the final value. So that is why it is called as a wraparound method. Whereas in a Opencv, if I do the same operation, my value will be clipped off at the maximum value. So it will never go beyond the maximum or minimum value. It will get something like a saturated value. It will perform clipping and it will ensure the pixel value never fall outside your 0 to 255. So there is a significant difference between how a arithmetic is performed by your NumPy library and how it is performed by a Opencv library. So in a NumPy, it wraparounds. After it exceeds the maximum value, it starts from the another extreme end. It starts from the 0. Whereas in Opencv, the value will get clipped off once it reaches a maximum value or a minimum value. So we will see some examples in the programming part on how it works for your NumPy as well as how it works for your Opencv. Next operation which I am going to discuss is translation. So translation is something like moving an image either towards right or left or towards top or bottom. So in a linear scale fashion, we try to move an image. So such an operation is called as a translation. It's shifting of an image along the x or y axis. So in order to do this translation process, we have to make use of a matrix, which is called as a translation matrix, M. So M is given by 1, 0, Tx is in the first row. Second row is 0, 1, Ty. So where this Tx and Ty represents the number of pixels which we need to shift along x direction and y direction. So Tx is number of pixels which I want to shift along x direction. Ty is number of pixels which I have to shift along y direction. So if Tx is positive, then the shifting will happen along right side. If the Tx is negative, shifting will happen along left side. Same way, Ty is positive, the shifting will happen down, whereas Ty is negative, the shifting will happen towards top. So each and every value in this Tx and Ty will play a role in the shifting process, either towards left or right or top or bottom. So once we define this translation matrix, this translation matrix can be multiplied with your image pixel values at a particular point. So that can be done using this warp-affine transformation. So warp-affine transformation is mainly used for your translation, rotation and for your scaling, which is something like a matrix multiplication. So I have a matrix here and we can consider the image as another matrix and then we do matrix computation. So for example, let me take a point x comma y in an image. So let us take it as 0 comma 0. So let us take Tx to be 5. So which means our translation matrix is 1, 0, 5. So Tx I have set it to 5. Whereas Ty I am going to give it to 0, which means I am going to just move my image towards the right by 5 pixels. I am not going to do any translation on the y-axis. Only on the along the x-axis I am going to do the translation. So 1, 0, 5. Second row is 0, 1, 0. So Ty I am going to take it as 0. So let us take the point in our image 0, 0. So what we do here? So M11. So M11 is nothing but 1. 1 into x is 0 plus M12 is 0 into y is 0. So 0 into 0 plus M13 is Tx. Tx we have taken 5. So which means 0 plus 0 plus 5. So I get a value of 5 here, the first value. Second value is M21 into x. M21 is nothing but 0. X is again 0. M22 is 1. Y is 0. M23 we have taken it as 0, which means 0 plus 0 plus 0. So what happens? 5 comma 0. So initially my point is 0 comma 0. Now the same point has been shifted to 5 comma 0, which means I have shifted my image towards right by 5 pixels. So same operation will be carried out for the entire image. Same operation we need to carry out for the entire image. Thereby, the image will get completely translated along x-axis or y-axis depending upon your tx and ty values. So this operation is called as a translation operation. Next operation which we will discuss is rotation. So rotation in the sense we are going to rotate an image to some angle. So here also we need to define a rotation matrix M, which is nothing but cos theta minus sin theta, which is your first row. Second row is sin theta and cos theta. The theta represents the angle of rotation in anti-clockwise direction or counter-clockwise direction. Negative value of theta means clockwise direction, right? Positive value of theta represents counter-clockwise direction. Negative value of theta represents clockwise direction. So this matrix again I can multiply it with the image matrix to get the rotation matrix. So we can also do certain operations in Opencv that I can rotate and also I can resize an image. After rotation, I can either increase the size of an image or decrease the size of an image. So two things can be done simultaneously using an Opencv operation. I can scale an image as well as I can also rotate the image with respect to the center point of an image or to any arbitrary point of an image. So in order to do that, we define a matrix M, rotation matrix M, which is nothing but alpha, beta, 1 minus alpha Cx minus beta Cy is the first row. Second row is minus beta, alpha, beta Cx plus 1 minus alpha into Cy. This is the second row, where this alpha represents scale value into cos theta. So scale value is nothing but whether my scale should be increased or decreased. If I put a scale value of 2, then the image will be doubled in size. If I put a scale value of 3, image will be tripled in size. If I put a scale value of 0.5, then the image will come to half the size of the original image. And cos theta, where this theta represents the angle of rotation. And it implies that if theta is negative, the rotation will be in clockwise. Theta is positive, the rotation will be in anti-clockwise. Same way, beta is defined as scale into sin theta. And Cx and Cy are nothing but the coordinates at which we are going to rotate our image. So by using this matrix, I can get both scaling of an image as well as rotation of an image. Whereas using this matrix, we will get only the rotation, not the scaling factor. So most widely used method in your rotation is this matrix will be used for your multiplication with the image matrix. So I can do both rotation as well as scaling of an image. Next operation which I am going to discuss is resizing. Resizing an image. So resizing means either I can decrease the size of the image or I can increase the size of the image. So while doing resizing, one of the important point to keep in mind is the aspect ratio of an image. What is aspect ratio? It is nothing but the ratio of the width of the image to the height of the image. So this ratio should be maintained properly. Otherwise, the image will look compressed or it will look distorted. So whenever we try to do resizing, either upscaling or downscaling, we need to maintain this aspect ratio. The ratio of width of an image to the height of the image should be maintained constant. Usually, for downscaling, for reducing the size, it is a little bit easier because we are going to remove certain pixels from the image. Thereby, I can reduce the size of the image. Whereas upscaling is much more challenging because now we are going to create a new pixel for which the value needs to be estimated. The new pixel value should be estimated, and this estimation depends upon the neighborhood of this pixel. So depending upon the neighborhood, we can estimate a value for this new pixel. So we have different methods in which we can do this estimation process. Those are called as interpolation methods. So the first method which I am going to discuss is your CV2.interNearest. So here I take a neighborhood around the newly created pixel and I try to see which pixel is closely related to this newly created pixel, and we try to retain that value. So that is called as a nearest, inter-nearest method, cv2.inter-nearest method. Next method is something like cv2.interlinear. So linear in the sense, again we try to take a neighborhood, put all the pixel values in a graph, try to draw a line y equal to mx plus c. Then we try to take a value in this line and assign that value for our newly created pixel. So this method is called as cv2.interlinear method. Same way, there are other methods using some mathematical operation. We can compute the newly estimated value like cv2.interarea, cv2.intercubic, cv2.interlandslock method. So these methods make use of some mathematical equations to estimate the new value for your newly created pixel. So since it involves a certain complex mathematical operation, the execution time will be little bit on a higher scale when compared to your linear method and a nearest method. So here it is just like in linear method, it's just a line fitting, whereas in case of a nearest, it is just by looking at the neighborhood, we try to take the appropriate value for the newly created pixel. So this will be much more faster, but the quality wise, it will not be that much good. If you are requiring a very good quality after resizing, then it is better to go with some cubic method or Landslock method, so that you will get a better representation of your original image. And one more thing you have to remember is this intercubic function, it works with a 4x4 pixel neighborhood, whereas Landslock method is working with 8x8 neighborhood method. So next operation which we will be discussing is flipping. So flipping means either I can do horizontal flipping or I can do a vertical flipping. So exchange of pixels. For example, in an image, the top leftmost pixel will be exchanged with the top rightmost pixel. So like that, when we try to do an exchange, we will get a horizontal flipping. In case of vertical flipping, the top leftmost pixel will be replaced with bottom leftmost pixel. So like that, if I do the replacement, I will get a vertical flipping. So those operations can also be done using your Opencv functions. Either in x-axis or y-axis, we can do horizontal or vertical flipping. And the last operation which we will be discussing is cropping an image. So cropping in the sense, we are trying to extract a region from an image. So to get or select a region from an image, we make use of this cropping function. So using this cropping function, usually we will try to extract a square region or a rectangle region or a circular region. We can extract it from the image. So if I want to extract some complex shapes, then we need to go with other methods like contour generation and then use that contour to extract the region. So right now we will talk about extracting an image or region of interest using the cropping techniques. Now let us go to the coding part. So first let us start importing our packages. I will just zoom the code. So first we will start with importing the packages. Like to see the image, I am going to use cv2_imshow function, which is available in the Google Colab patches. Then matplotlib, it supports Python plot. So we are going to make use of the Python plot, and in short form we will try to use it as PLT. Since we will be working with some matrix operation, we need to have a NumPy library, which is numerical Python library. In short form, we will be using it as NP. And argument pass we are not going to use in this function, but this function will be helpful whenever we try to give the data during runtime. And here I am going to introduce a third-party library called as IMUtils. So we can do translation, rotation, resizing using normal Opencv methods. We can also do the same operation using this third-party library IMUtils. So this will be much more convenient and easier to use when compared to your Opencv functions. So that we will look at when we discuss this program in detail. So this is the IMUtils, is a convenience function where we can do translation, resizing and rotation, cropping, flipping, everything we can do with the help of this IMUtils function. Same way CV2 is a computer vision version 2 package. So these are the packages which we are going to use in our program. So let me run this cell. It gets executed and there are no errors. So first thing what I am going to do is I am going to upload an image from the Google Drive environment. So I am going to use this Google Colab, import files, and I am going to use this upload function to get that file and put it onto a variable uploaded. So here I am going to run this cell. It will ask for the location. So I need to select a location. So I go and select a location where I have my program. So I am selecting apj.jpg image file. Now it gets loaded into this uploaded variable. Now I want to see the image. So in order to see the image, first I am going to read that image using cv2.imread function, and then I am going to visualize that image using cv2_imshow function. So when I press this, you can see this is the image which we have uploaded into our Google Colab environment. So now let me show the first operation, image arithmetic. So where we are going to do some addition and subtraction operation using both NumPy as well as your Opencv. How the values will be different, so that we try to understand now. So first thing is I am going to do addition using Opencv. So here you see cv2.add function will be used for adding two values. So here I take one value is 200, another value is 100. So we define a NumPy array and we add the values in the NumPy array using cv2.add function. So 200 plus 100, it is equal to 300 normally. Since it exceeds 255, in CV2 what happens, the maximum value will be retained. It will never go beyond your maximum value or minimum value. So that is what happens in your CV2 based arithmetic operation. Same way I am trying to do here subtract operation. I take two values, 50 minus 100, which means minus 50. So here also we will never go beyond your minimum value. Minimum value is 0. Maximum value is 255, minimum value is 0. When I do Opencv based addition or subtraction, it will never exceed your 0 or 255. When I execute this, you can see it prints maximum of 255 when it does the addition operation. Same way minimum of 0 when it does the subtract operation. When I do the same operation using NumPy, we will try to see what happens. So here I took two arrays, 200 NumPy array as well as 100 NumPy array. I try to add these two values. So it's a NumPy based addition. So now what happens, the value will get wrapped around. Same way here I do 50 minus 100. We will look at the output, how it wrap arounds. So when I run this, you can see now the value for your addition is 44, which means 200 plus 100. So 100 we have 55, so that comes from 200 to 255. Then remaining I have 45. So 45 it starts with 0. So 0 to 44. So the final value is 44, which is a wraparound value of this addition. Same way in case of a subtraction, 50 minus 100 means, so 50 gets removed here and then it gets reduced from 255. From 255 if I reduce, it comes to 206. So it wraparounds. The value gets wraparound. So that is how the addition and subtraction in NumPy and your CV2 is completely different. Depending upon your application, you can select what type of arithmetic you want to perform on your image. Now let us talk about how to add two images. So in order to do that, first I am going to create a unit matrix with the shape of the image. So dot shape function will give me channel information, width information and height information. Based upon that, I am going to create a unitary matrix. And this unitary matrix is multiplied by 100. So all the pixel values will be with 100. So now I have a matrix with 100 as a value for all the elements, and it is with the shape of your original image. Now I use cv2.add the image with the matrix. So after adding, I try to visualize the original image and the added image. So when we try to do that, we will see this is the original image. After adding 100 to each and every pixel, so we are adding 100 to each and every pixel of this original image. You can see the image got brighter because it goes to the maximum value of 255. Since I am adding 100 to each and every pixel, it goes to the maximum value of 255. So thereby the image looks brighter. In the same way, we can also do subtraction. So here also I create a unitary matrix of same size as that image and multiply it with 50. So we are having a matrix with elements 50. And I am going to subtract using CV2 arithmetic image with the matrix. So then again we make a comparison of original image with the subtracted image. Since here we are doing subtraction, now the pixel intensities are going towards the 0. So it becomes darker. The image looks darker due to subtraction of 50 from each and every pixel. Next operation which we are going to discuss is translation operation. So as I said, in translation, first thing is we need to define our matrix, translation matrix. For defining the translation matrix, I use this np.float32 function. Values are 1, 0 and 10. 10 is nothing but the tx value. Tx value in the sense the number of pixels which I want to move along x direction. Positive value means the image will be moved towards right. Negative value means image will be moved towards left. Same way, second row 0, 1 and ty. So ty I am going to use 50, which means I am going to move the image towards down by 50 pixels. So I am going to move the image towards right by 10 pixels and also I am going to move the image down by 50 pixels. So this defines our matrix, translation matrix. So now we have to do the matrix computation between our original image and the translated matrix. So in order to do that, we make use of this warp-affine function. So cv2.warp-affine function will take the image and the translation matrix and it will do the matrix computation. For how many values? For the entire image. So dot shape of 1 will give me width information, dot shape of 0 will give me height information. For the entire width and height, we are going to do this matrix multiplication. So then we try to print the image, both the original image and the shifted image, to see the difference. When I run this, you can see this is the original image. Now you can see the translated image. The image has been translated towards right by 10 pixels and towards down by 50 pixels. And the translated region, you can see it is black in color. So that is how we can do the translation along x-axis and y-axis. If I use negative values, then the translation will be in opposite direction. Here you see I have used a tx value of -50, which means I am going to move the image towards left by 50 pixels, and a ty value of -70, which means I am going to move the image towards top by 70 pixels. Again use the same function. Then after shifting, we try to print it and see. So now we will see that the image got translated along left direction and towards top by 50 and 70 pixels respectively. So here in Opencv, one important thing is we should remember this matrix to do that operation. So this can be eliminated by using a imutils function. So as I said, imutils is a convenience function which makes life little bit easier. So for example, I can do the same operation using the imutils function. I just give imutils dot translate, I give the image and the tx value and the ty value. So automatically the matrix will be computed and the matrix will be multiplied with your image and we will get the shifted version. So here we need not worry about the matrix values and all. So just give your original image, tx value and ty value. So here I am not using any tx, ty I am set it as 80, which means we are going to move the image towards down by 80 pixels. You can see the result. The same operation is being performed by imutils, but it is little bit easier for the programmer because they need not worry about the translation matrix and all. So just give the tx value and ty value, automatically the matrix will be computed and the matrix will be multiplied with your image to get the shifted version. So next thing which we are going to discuss is a rotation of an image. So to rotate an image, we need to have a point. So we need to rotate about a point. So first let me take height and width of an image by using the dot shape function. So dot shape function :2 represents, I will get both index with 0 and index with 1. Index with 1 will have a width information, index with the 0 will have a height information. So both the values will be obtained in this h, w. So after obtaining h, w, we can use this information to compute the center point. By computing w by 2 and h by 2, we get center of x and center of y. So then we can use the center point as the point where we can rotate. So again for rotation, we have to construct a matrix. To construct a matrix, we use a function called as cv2.getRotationMatrix 2d. So this function will take the point of rotation and the angle. Here I specify 45 degree, which is a positive value, which means we are going to rotate our image counterclockwise. And the last value is a scale function. So whether my image should be same size after rotation or it can be doubled or half the size, that we can decide. So 1 means we are not going to change the scale of your image. If I want double the size, you can give 2 as a scaling factor. If I want half the size, I can give 0.5 as a scaling factor. So once we have defined our matrix, again we do the same warp affine function to multiply this matrix with the image for the entire width and height. So thereby I get a rotated image. When I execute this, you will find this is the original image and now the image is being rotated counterclockwise by 45 degree. Same way I can use a negative value here. Here you can see we have used a negative value, which means now the image will be rotated along clockwise direction. So that is the difference here. Again we define a matrix, use a warp affine function to do the matrix computation. So when I execute this, you can see original image. Now the image is rotated by 90 degrees in clockwise direction. So instead of using the center point of my image for rotation, I can also use any arbitrary point for rotation. So that can be done using this center point minus 50, center of y minus 50. So here I am choosing a little bit distant point from my center of my image. So this can also be done. So we can rotate an image about the center point of an image or through any point. So that is what we try to do here. So again when I execute this, you will see the image will get rotated with some arbitrary or shifted point from an image. Again, as usual, for our translation, Similar to translation, we can also use IMUtils function for rotation operation, which makes our life a little bit easier. So I need not worry about the matrix and all, just give the value of rotation. So IMUtils dot rotate, I just give the theta value. So positive value means counterclockwise direction, negative value means it will be clockwise direction. So it makes the programmer's life a little bit simple. So here you see the image gets rotated counterclockwise direction by 180 degree. Next operation which we are going to discuss is resizing operation. As I said, while resizing, we need to maintain the aspect ratio, thereby the image will not look a little bit distorted or skewed. So what is aspect ratio? Aspect ratio is nothing but width by height information. So let us take the first example. I need to have a width of about 150 pixels. After resizing, I should have my new image with 150 pixels width. So in order to do that, what we need to do is first we need to compute the ratio between the new width after resizing to the original width of the image. Original width of the image is obtained by dot shape of 1. This gives the ratio. So this is the value which I want after resizing. Right? The width information of my image after resizing, I should want it to be 150 pixels. This is the width information before resizing. So I take a ratio of this to get this R. And this R will be used to adjust your height information after resizing. So the dimension which I want is width should be 150 and the height information is image.shape of 0. It is multiplied by R, the ratio which we compute here. As we have a ratio on the width of the images, the same ratio should be maintained for your height of the images also. So we try to manipulate our height information. Then for this new dimension, we need to have our resized image. To perform resizing, I use this function cv2.resize. cv2.resize, I give the original image and what should be the dimension after resizing. That is specified here. So that is nothing but 150 comma R multiplied by your original height information. And here, while resizing, we have to specify a method. As I discussed a little bit earlier, we have different methods like inter nearest, inter area, inter cubic, inter landsarc. We have to specify the method by which our resizing should happen. So here for this application, I have used inter area. You can use your cubic or landsarc and you can see the difference. So after resizing, I try to see and compare it with the original image. When you see, when you execute, this is the original size. So after resizing, it becomes smaller. So here you can see the aspect ratio is maintained, thereby the clarity of the image is also maintained. Same way, we can also do the opposite. I want a fixed height. So for having a fixed height, I can estimate what should be my width. So for example, if I want the height to be 50 pixels after resizing, then what I do, I compute the ratio. Now, after resizing, I want 50 pixels. My original image height is given by dot shape of 0. I find the ratio. Now the width is altered. Width is altered as per this ratio and the height is fixed. We get the new dimension. Then use this new dimension for computing the resized image. Here you see I have used the interpolation method as cv2._area. So when I run this, again you can see original image and a resized version. So instead of this, again I can use IMUtils function for resizing, which is a convenience function. So just use IMUtils.resize. Image, I give what is the width. Automatically the height will be computed. Once I give the width, this is the destination width. After resizing, what should be my image width? So once I give this, automatically the height will also be computed and it will be used in your resizing operation. So you can see the same resizing has happened. Next thing is I am going to use different methods to see which method gives a better result. So I define a constructor named methods. Here I define all the methods, like I give a name for each method and the function for each method: nearest, linear, area, cubic, landscape. So in our for loop, I am going to take the method one by one, and I am going to apply the method one by one to my original image, and we try to plot it and see which method gives a better result. So in a for loop, I take all the methods and I am going to take one by one name of the method and the method. For example, when the for loop runs for the first time, the name of the method is cv2.interNearest. Method is cv2.inter_nearest. So for this, I try to use the resize operation. So I want the image size to be 3 times larger, and I use the method given here. So for each time, one new method will be taken and it will be used for resizing an image 3 times the original size. Then I try to plot it and see. When I plot it, this is the original image. You can see this is the resized image. So when you look at this image, you can see the landscape will give you much better resizing. So this is first one with linear, not linear, nearest. First one with nearest, linear, area, cubic, and landscape. Okay, so you can see the different images, and when you closely look at it, you can see the landscape and cubic will give much better resized image. The next operation which we are going to discuss is flipping. Flipping, as I said, I can do both horizontal flipping and vertical flipping. Horizontal flipping means top left pixel will be replaced with top right pixel. So like that we try to do for the entire image. So in order to do horizontal flipping, we make use of a function called as cv2.flip image, and we give a flag value of 1. So 1 indicates we are going to do horizontal flipping. So I try to show the original image and the flipped version. So you can see here, this is the original image. So now in flipping, what we do? We take the top leftmost pixel, replace it with the top rightmost pixel. So like that we try to exchange the pixels from this point to this point. So thereby you can see there is a flipping in the horizontal direction. Same way we can also do vertical flipping. To perform vertical flipping, we have to provide a flag of 0. So this will do the vertical flipping. When I do this, you see now what happens? The top left pixel, will be replaced with bottom left pixel. Same way top right pixel will be replaced with bottom right pixel. So by doing that, I will get a vertical flipped image. We can also do both horizontal flipping and vertical flipping together. So in order to do that, we can supply a flag value of -1, which means first the horizontal flipping will be done, then the horizontal flipped image will be vertically flipped. So that is what happens when I support a flag value of -1. So first an horizontal flipping will take place, then the horizontal flipped image will be vertically flipped to get this new type of image. Here you see the original image. First horizontal flipping will be done, then the horizontal flipped image. So when I do horizontal flipping, this image will come on the right side, this image will come on the left side. Then I do vertical flipping. When I do vertical flipping, you can see when this image comes on the right side, when I vertical flip, I will get this new image. So we can do horizontal flipping, vertical flipping, and we can combine both the things also. And the last operation which we are going to discuss in this program is cropping. So cropping is done very easily by providing the coordinates. So I am going to crop from coordinate 5 to 130 and 5 to 130, width information and height information. So image of width from 5 to 130, height of from 5 to 130, which means from the 5th pixel to 130th pixel, and for height also from 5th pixel to 130th pixel. We are going to extract that region and we try to see. So when I run this, you will see the extracted region. So only the face region got extracted and cropped. So in this program, we have discussed about certain things like how to perform image arithmetic, addition and subtraction by using both Opencv as well as NumPy. Then we discussed about how to do translation operation. So right side movement, left side movement, top and bottom movement. Then rotation, how to do rotation, how to perform resizing using different methods like nearest, linear, area, cubic, Langsock methods. Then we discussed about flipping an image, horizontal flipping, vertical flipping, combining both the things. Then finally we discussed about the cropping, extracting a region of interest from the original image. Thanks for watching. Please subscribe for more technical learning. You can also visit my website to look at the research activities which we carry out in our lab. Thank you.